Hello and all, my name is Francis and today I'm going to present to you my microcontroller-based vending machine. This machine can sell up to 10 different products and it uses the industrial-grade microcontroller PIC16F887. This microcontroller was chosen because it can retain data for long terms of time and it can work uninterruptedly all day long. This machine was built using basic blacksmithing tools. It was designed using SolidWorks. Its electronic board was designed using KiCad, and the code was developed using CCS compiler. Remember that you can have access to the diagrams, the schematics, the code, and the SolidWorks files in the link that is found in the description. But by now, I cannot give you the full code, okay? So I will only provide you a basic code that will make the machine work using the barebones configuration. Okay, so with that said, let's go with the explanation of each step of this machine. Okay.
So here we are, the SolidWorks simulation. Okay, as you can see here, I modeled every component from scratch. This is the conceptor, the LCD screen, the arcade buttons, the PVC piping, the pumps, the anchors, the tubular hinges, the padlock holder. Okay, so what's important in this video is that I mentioned you which components I used or which materials. Okay, so I use an 18-gauge galvanized steel sheet. It would have been better to use a stainless steel sheet, but since I don't have the equipment to weld that kind of steel and I don't have that amount of money, that's why I use galvanized steel sheet. Okay, so the rest of the components you see here are just normal carbon alloy steel. Okay, so I use this 14-gauge 1-inch square tubing to create the machine. I essentially made a box. Okay, and well, I use these 3/8 of an inch square bars to give support to these pumps, as you can see here and here. I use 3/4 by 1/8 of an inch flat bars, and I made some 3/16 inch boards here to pass the screws for the pumps. And well, I also use these 3/8 of an inch threaded rods. Okay, and well, these rods are used as anchors to firmly attach or fits the machine to the wall that's going to be around here. I also placed some galvanized steel sheets around the machine, so it is completely protected against the environment. And well, what's important with this machine is that I use a lot of rivets here. I use 3/16 of an inch by 1/4 rivets. Okay, and well, I think that they are very resistant. And I also use 3/8 of an inch tubular hinges to give motion to these doors. And well, let's take a look at what's inside of this control panel. Okay, so here we have the conceptor attached, LCD screen, and well, this is the control panel. I'm using an FDF panel. Okay, So I also use these tiny anchors to fix the MDF panel to the machine. Okay, and well, that's pretty much it for the SolidWorks simulation. It's not that complex. I think. I mean, this machine doesn't have any mechanism. It's just the pumps, well, the PVC piping, and that's it. Okay. Remember that you can have access to the full schematics and all the components in the link that is below in the description. So now I'm going to start a quick explanation of this code. As you can see here, this is the first block. In this block, I am defining all pertinent configuration settings. For example, the fuses, the I2C communication, and the library. Remember that you can have access to this library in the description below. And well, these are some settings I'm going to use throughout the program to define its behavior. These are the macros I use to create the program more readable. This is, well, this part of the code is very interesting because here I have a English version with the names, for example, lemon, grapes, orange, etc. And this is the Spanish version I'm going to use in real life, okay? And well, just keep in mind that when I refer to product number 1, I refer to lemon, product 2, grapes, etc. But when I refer to the product index, I refer to the number of product minus 1. For example, product number 1 has a product index of 0. Product number 2 has a product index of 1. And so on until Pancho Cola, which has a product number of 10, but its product index is 9. Okay? So, well, these are some pins definition. I think that they are very self-explanatory. These are some prototypes that I'm going to define in the code. Okay, and this part is very interesting because well, this is another way to make the EEPROM memory management more flexible. Okay, as well, I'm just using some definitions I created earlier. For example, the product's number, well, it's here. I'm just using it to make the code more readable and more flexible. Okay. So now it's time to explain the global variables I'm going to use throughout the program. For example, this key variable is very important. This key variable will store the value returned by the keyword function. The keyword function will be used to analyze the bottom matrix and return a valid value. Okay. And for example, well, these 4 arrays that you see here are going to be used to store data in the RAM memory. They will charge for example, the prices, the availability, the timing calibration, and the names. They will charge all that data from the program memory into the RAM memory, so you can have a faster access to this kind of information. And now we have this other variable, which is called the selected product variable. Okay, this variable will be used to store the index of the product we are currently working with. Okay, so for example, it will store 0 for the first product, 1 for the second product, and so on. We also have these 3 volatile variables. For example, the credit variable that is going to be used to store the current credit, the previous credit that will be used to check if everything has changed so far. And we also have this money-inserted variable, which we'll use only as a flag to indicate to the program that the credit has changed and it has to be updated in the screen. Okay. And we also have this very interesting array, which is called matrix. It's a bidimensional array. And well, as you can see here, it stores the associated character to each button. So if you want to maybe use another set of characters, you can actually do it. Just change it using this matrix. Okay. And well, this is one of the most important parts of the code. I'm not going to go into much detail with this one. But well, what this interrupt service routine actually does is that it will be executed every 250 milliseconds, okay, or every 1/4 of a second, and it will constantly check the output provided by the counters. And if that output change, it will well, detect in some way and will mask that value. In this case, using this bit mask, and it will update the credit counter, and it will obviously reset the 2 counters, and it will turn on this flag that I mentioned earlier. Okay, so don't forget to add this interrupt service routine, because otherwise your program will not work. Okay, and well, have reached the main part of this code, which is the main function. Okay, here I'm just doing the same process that I use with other programs. I'm just defining the three state registers for the outputs for the GPIO of the microcontroller. I am setting the timer, and I am disabling all interrupts. Okay, and well, here I'm just setting up the LCD screen. I am charging from the program memory into a RAM memory using this product names array. And I am populating these three arrays that I mentioned earlier. I am resetting the counters in case there's some undesired garbage value stored in them. And I am activating the pumps. Actually, I'm going to use this command throughout the program to control the pumps, okay? To control the relay modules. But with this keyword, I'm going to disable all pumps. Okay, so it's kind of contradictory, but just stick to it. Okay, now we are going to use this statement to enable both relay modules. Okay, and well, this is the very important part of the code. This is the main loop. This loop will be executed forever. Okay, forever. There is no way to escape from this loop. There is no secret sequence of buttons to escape. No, there's no way to escape from this loop. Okay, and well, what this loop essentially does is just the routine used to sell a product to the customer. Okay, so in the first part of this loop, I'm going to be initializing the interrupts and the key. And well, I also going to dive into this other loop, which will be constantly checking if the user has input a coin, and if he has actually pressed a button. Okay, if he has done so, we are going to check if that product is valid, okay, or if it's available. For example, I'm going to use this macro to convert the key and check if the product is if the value is a product, okay? And then once I have the index of that product using this macro, I'm going to check if the product is available. If it's not, I'm going to say, excuse me, the product is not available. I'm going to escape the loop and going to start from here, okay? And for example, if you have insufficient credit to purchase that product, I'm going to say, excuse me, bro, insufficient credit, and I'm going to escape that loop, okay? Going back here, okay? Well, if the user has the sufficient amount of money and the product is indeed available, I'm going to escape this loop that I mentioned you, and I'm going to decrease the credit of the user by the price of the selected product. I'm going to show the name of the product, and I'm going to show the message selected and dispensing product. Then I'm going to disable all interrupts just to avoid any kind of timing issues, okay? And then I'm going to activate the corresponding pump. In this case, the selected product plus one, okay? And well, this for loop is kind of interesting because, well, these two tiny delay calls are going to equal to a 100 milliseconds delay, okay? So every time this loop has an iteration, I'm going to include a 100 milliseconds delay. So what it means that this machine is going to be calibrated using time because we don't have enough budget to use flow sensors, okay? So if you want, use flow sensors. That would be the best way, the most reliable solution, but in this case, we are just using time, okay? For example, what this actually means, in other words, is that we only have a 100 milliseconds resolution. So if you translate that to the amount of liquid that you can pump in 100 milliseconds, that's just to say, that's the precision of this machine. Obviously, you can use smaller delays, but that will affect other parts of the code. Okay, and Finally, we are going to disable all pumps using this statement. And we are going to show this message called thanks for buying. Okay. And well, that's it for the main part of this code. Remember that I have an enhanced version of this code that actually includes the admin menu to configure manually, semi-automatically, better said, these variables. But by now, I think it's sufficient for you to perhaps manually changing the EEPROM values before uploading the code to the microcontroller. But feel free, if you want, to maybe write your very own admin menu to change these variables, okay? So now let's somewhat review this function. For example, this is a very basic one. This is called the scan keypad function. It will just scan the keypad. We also have this keypad function, which will be used, as I said earlier, to check which keys have been pressed, if it's not a null card, if the money has been inserted, we'll update that with the current credit, etc. We also have this activate pump function, which will update the shift registers so they can actually show activate the corresponding pump. Okay. We also have these two tiny functions that will be used to prevent inlining and save some memory. And we also have this print string ROM, which will be used to print a string that's charged in the ROM memory. We also have this clear screen function. We also have this show names function that we will be used to print the name. And well, this is one of the this is the longest function I'm going to use in this program, which is going to be used to show a message using this switch structure. Okay. For example, message number 1 is going to be used to say insert coins or insert dinero in Spanish. Okay. And well, I think that's pretty much it for this code. All right, so now let's explain the electronic diagram I'm going to be using for this circuit. Okay, so I divided the circuit into several blocks, and I use these labels that you can see here. For example, counter 0, counter 1, counter 2 are labels, and I added them to avoid having to make so many wires. Okay, so now let's explain each block. Okay, so this is the most important block of this circuit. This is a big microcontroller. I use these labels and they are well defined in the code that I provided to you in the description. And well, I am just supplying this PIC with this 5 volts power source. This is a power supply block. I use this power supply, which has an output voltage of 12 volts. It can supply up to 20 amps, and it has an output power of 240 watts. It's connected, obviously, to the electric grid. And I'm going to convert those 12 volts into 5 volts using this 7805 linear regulator. And remember always to use its corresponding heatsink. And I added this 1000 microfarads volt capacitor because the rest of the components have a high current consumption. Okay. And I added finally this green LED to indicate that the power source is working as expected. And well, these two labels are going to be used throughout the entire diagram. This 5 volts power source is connected here, and this 12 volts power source is connected directly to the output of the power supply. This is the LCD screen block, and well, this is a LCD 1602 LCD screen. It has a built-in I2C communication module, so we can just control this screen using two lines. Okay, I also added these two 3.3 kilo ohm resistors because they are mandatory for I2C communication. And well, that's pretty much it. I use this instead of the normal setup that requires around 8 lines because, well, to save pins to add more features in the future to this machine. Okay, so now I'm going to be explaining the boron matrix block. Well, as you can see here, this is a normal layout used for boron matrices. You can find this kind of layout online for Arduino projects, for commercial products, etc. And well, as usual, I added these two pull-up resistors. Well, I also added this, this button and this switch. This button is used for the enhanced version of my program. And well, this is a special function button. And this is the mode switch, which is going to be used to change the mode between admin mode and normal mode. Okay. And well, in your case, you can change the function of each of these switches or even add more switches if you will. Okay. Okay, so now it's time to explain one of the most complex blocks in this circuit, which is the shift registers and relays block. Okay, what this block essentially does is that it controls these 10 pumps. Okay, it controls these pumps using these two 8 relay modules, which work with a operational voltage of 12 volts. And these relay modules are controlled directly by these two shift registers. Okay, these two 74HC595 shift registers. Okay, and well, there are a couple of safety considerations that were applied to this circuit. For example, here we have two decoupling capacitors attached to the supply pins of both 74HC595s. Why? To filter any kind of interference caused by the switching and commutation of these circuits. Okay, we also added this fuse. So if there's a short circuit in one of these pumps, the entire system, well, the pumps are just disabled. Okay, and well, it would have been better to use a fuse for each pump, but in this case, and due to budget constraints, we only added one fuse. Okay, and we also had this other safety, how do I say it? This safety consideration, which is this pull-up resistor that is connected to this 595 output enable label. Okay, what this essentially does is that on a startup, these chips are set to 0. Okay, and the problem is that these relay modules are active low. So during startup, all relays and therefore all pumps are activated, and we don't want that. Okay, so what we do here is that on startup, this pull-up resistor that is connected directly to the 5 volts power source will hold up this output enable pins of both shift registers, and the state of the outputs will be high impedance. Okay, so once the peak has already been properly initialized, it will set this pin to low, and both shift registers, which already have a pre-charged correct value, will be actually enabled. Okay, so yes, that's a very, very important consideration that you should follow. Okay, and well, that's pretty much it for this circuit. What can I say? For example, these two shift registers are placed in a cascade fashion. So the output of this shift register, the last bit, so to speak, is connected to the first bit of this shift register, and so on and so on. If you would like to add more pumps and products. Okay, and it works backwards. If you want to use fewer pumps, you could for example use only 8 products, and therefore this relay module would be useless and this one would be useless. So you would only use one shift register, one relay module, and only 8 pumps. Okay, but well, in this case, why do I use 2 shift registers if, for example, my peak has 10 peaks available? Well, I did that because I want to save pins to have more space for future enhancements to my machine. For example, if I want to add maybe a hopper, LED lights, etc. Okay, so now let's go with the next module. Okay. All right, so here we are at the connect acceptor block. This is the trickiest block of all of them, because if you directly connect the pulse output to the input of your counters, you will absolutely 100% guarantee that you will get problems. Okay, maybe not now, but absolutely in the future. Why? Because this output of the condensator is very dirty. Okay, so if it counts a pulse, it will bounce a lot, and you will not get reliable results. And for example, your credit counter will go from 0 to 100 to 150, and then to 200, and it will reset. So it's not reliable at all, and that's why you really need to add this two-stage filter. Okay, so we're going to connect the pulse output directly to the optocoupler, okay, to drive this infrared LED, and we are going to use this 390 ohms resistor to protect the LED. And well, when the condensator detects a coin, it will pull down this line directly to ground, so it will complete the circuit for the infrared LED. And why did I use this optocoupler? Because this condensator works with 12 volts, as you can see here, and the system that we are working with works with 5 volts. And even though this is a TTL output, I don't really trust the reliability of this condensator. So that's why I use this optocoupler, okay, to electrically isolate this part from this part, okay. So then I use this simple array of transistor to control this Schmidt trigger, okay. This, as you already know, the Schmidt triggers are used to handle hysteresis, high hysteresis, and well, we'll get absolutely fine pulses from the condensator, okay? And now we are going to connect this block to the second block. So this is the final block. This is a 6-bit counter block. And as you can see here, we have two 74LS93 ripple binary counters. And well, the input of the first counter, well, excuse me, the clock of the first counter is connected to the condensator output. And the final bit of the first counter is connected to the clock source of the second counter, okay? And since you only need 6 bits, okay, we don't connect the two last bits of the second counter, okay? And we also added these two decoupling capacitors. Well, when the program needs to reset these counters, when it has already read the two counters, it resets them using this label, okay? And we read the information from these counters using these 6 labels, okay? And well, that's pretty much it for this electronic diagram. Here you have welded all screw terminals to the main board, okay? And I installed the power supply and the 5 volts regulator. I connected it to the power supply. And now I am testing with a multimeter the output of this regulator. And I am testing the LCD screen, just displaying some hello world stuff. And I am checking that the special function button and the mode switch is working correctly, okay?
So now let's focus on how this machine works. To do that, I'm going to enter the admin mode. With this admin mode, you can control various settings of the machine, such as the price, the product availability, the calibration of the pumps, etc. Okay, so now I'm going to refer to this button as button number 1, this as number 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is a special function mode button. Okay, so to enter admin mode, I first have to turn off the machine. Okay. So now that the machine is turned off, I'm going to go back here and then I'm going to switch this tiny little switch, as you can see. And now I'm going to repower the machine. So this is the menu. With button number 1, you go to a net setting, and with the special function button, you can access that specific setting. So The first setting is the change prices setting. So I'm going to hit the special function button. It says choose a product. In this case, you have to choose the product you want to change its price. In this case, I'm going to choose product number 7. Okay, so one to increase, two to decrease. All right. So by now the current price is 10 pesos. Okay, but I can decrement that price. 8, 7, 6, 5, 4, 3, 2, 1. The minimum is 1 for security reasons. Well, I'm going to set it to, let's say, 20 pesos. Okay, so now that price is set to 20 pesos if I press the special function button. Okay, so now whiskey costs 20 pesos, right? So I can choose another product, such as in this case orange. Okay, one to increase, two to decrease. The current price is 25. Well, I'm going to set it maybe to let's say 10. Okay, I'm going to set it to 10. I'm going to press the special function button. No, it costs 10 pesos. And well, these prices are stored in the pro memory as a 1 byte integer. Okay, so now I'm going to hit the special function button to exit this setting. Okay, so now I'm going back to the menu. So now I can see the sales report. Well, the sales report is used to see the sales of each product. In this case, I'm going to select product number 7. It says that I have sold only 51 units of this product. I can choose another one, such as soda. In this case, only one. For example, orange, only zero. Well, zero. Grapes, zero. Lemon, one. And well, pancho cola, six. So with this setting, you can see the different sales of each product. Okay. So now I'm going to go to the resale sales report. But before we go to that setting, let's see another setting that is a little bit more useful, which is the total sales report. In this case, if I press the special function button, you can see the total sales. In this case, 804 pesos. So now I'm going to go to the resale sales report. Okay, I'm going to hit enter. It says confirm, 1 for no, 2 to yes. In this case, if I want to delete the sales report, I can press the second button. So it says data deleted. So now if I go to the total sales setting, it says 0. And the same will happen with the sales report setting. In this case, I'm going to hit enter again, choose a product. In this case, let's say the 7th product, whiskey, 0. Pancho cola, 0. Okay, so it works. I'm going to exit the setting. And now I'm going to go to the product availability setting. This setting is used to change the availability of each product. In this case, for example, I can select Pancho Cola, okay, and I can choose where I have to enable it or not. In this case, if I want to disable this product, such as, well, for example, I would like to do this because well, I don't have this product anymore, the pump is no longer working. Well, there are just so many reasons to disable a product, but in this case I'm going to enable. But let's say that I want to disable the first product, in this case the lemonade. I'm going to press 1. Now it says disable. Okay, I can choose another one like grapes. I can disable it. Okay, in this case I'm going to say no, and I can disable all products that are no longer operative, okay, or available. And I'm going to exit this setting, and I'm going to go to the next setting, which is, well, in this case, the calibrate pump setting. Well, this is one of the most important settings, and this setting is used to calibrate the pumps. Okay, so I'm going to enter. Okay, and well, I'm going to choose a product. But before we do that, I'm going to place a container. Okay, so the container. Well, I'm going to to stop pressing that button when it hits this mark. Well, the this recipient is filled up to that mark. So I'm going to press it. It's almost there. Right. Okay. So now the machine has reached that point, as you can see here. Let me check. Yeah, it's here. Well, it's a little bit tilted, but anyway. So now the machine has recorded the amount of time it took the pump to fill the this bottle with that amount of product, and now it has stored that time in its EEPROM memory. So next time I want to fill that product, it will be exact. Okay, so I didn't use sensors. In this case, flat sensors because they were way too expensive. And well, remember that this machine had to be as cheap as possible. All right. So now I'm going to go to a net setting. In this case, it is the pump liquid. Well, this setting is just to pump liquid without doing anything special, just in case you have done some maintenance and you want to fill the pieces with liquid. I'm going to enter that setting and I'm going to press the same button and it's dispensing. It just dispenses that product. It doesn't do something special. Okay, so now I can exit that menu if I press this button. Okay, now it says turn off the mode switch. That's in the back of the machine. I'm going to turn it off, and when I do it, it goes to normality. Okay, so now I can again do the same thing that I did before, but well, anyway.
All right, so before we start with the manufacturing, I just want you to know the list of materials, components, and tools I used to create this vending machine. You can also have access to the complete list and all the schematics shown in this section in the description below. The first step is to set the chop saw 45 degrees and start cutting the pieces that will conform the two frames. We are going to use these two frames to create the two doors to protect the machine. Remember always to use your safety equipment to avoid any injury. So this is the result. As you can see here, the pieces matched together. Okay, and now I'm going to create the boards to pass the rivets. And I'm just taking the measurements to make sure that all pieces have the same dimensions and spacing between holes. So this is the result. As you can see, each piece has its own set of two holes, and I am welding these flat bars to create the frames. Okay, I'm using an A6013 electrode. Just remember that if you have access to stainless steel, you can probably create this machine using stainless steel. Then grinding each corner to make sure that all corners look smooth and fine. And this is the result. You have to do this same process with the other door as well. And this is the steel sheet I'm going to use. Okay, so I'm going to cut the steel sheet to match the size of the doors. Okay. cutting with the angle grinder. Now I'm drilling the holes to pass the rivets. Okay, I'm riveting the steel sheet to the door frame. This is a very simple process. Okay. And also, if you have access to a stainless steel sheet, it's far better to use that instead of galvanized steel. So this is the final result. Okay. So you can see both doors. Okay. They match perfectly. And well, now I'm doing some sanding with the angle grinder just to make sure that everything looks absolutely fine. Okay. And I'm just correcting some defects that the door had. And nothing to worry about, okay? So this is the final result. Now I moved the rivets to the correct places, okay? So now I'm going to cut the thread rod. I'm going to cut it in four rods with the same length, and now I'm going to cut the PTR piping, okay? This is to create the main frame, okay? This is the main structure of the machine. That's why it has to be very solid. Okay. So now it's time to cut the flat parts. So we're going to use to create some anchors to lay some rivets or screws, okay? We'll see that later. I'm going to cut some pieces at a 45-degree angle. Okay. Well, actually at 90 degrees. And at 45 degrees. And I'm gonna weld the main frame of the machine. Okay. I just want to make sure that everything is just perfect. Okay. To avoid any problem with unaligned pieces or profiles. Okay. Remember if you have some suggestions on how to do this process maybe more efficiently or more accurately, you can definitely post your comment in the comment section. Okay, feel free to do so. Still well in some profiles. It's time to weld the final part of this frame. Okay. I think I'm gonna use some jigs in the future just to make this process more efficient. All right, so now we have to create a second frame that will have the same dimensions that has the main frame that we just created. And this is the final result, and we are going to cut a steel sheet so it matches these two frames that we just created. This is the first steel sheet. And this is the second steel sheet. And I am drilling the holes to pass the rivets. So this is the final result, and it is the setup I used to rivet these two frames. And now I'm going to take down the seal sheet. This is the technique I use, and remember always to use your safety equipment, especially your safety boots, because if that seal sheet falls directly into your toes, it will definitely create an injury. Okay, so just be aware of that. And well, this part is especially for those of you who maybe don't have a special technique. Okay. And now I'm creating the complete frame or structure for the machine. And well, I'm going to use these 4 square pipes of the same length to connect the 2 frames that we just created. And now we are going to create the 2 side metal panels that will cover the machine using the angle grinder and obviously your safety equipment. And now we are going to place the rivets using the electric drill and well, using the riveter. Okay, and I used placing these clamps to make sure that the steel sheet is perfectly fits to the structure. And this is the final result. all metal panels are currently placed using rivets, and now I'm going to use these 3/8 of an inch steel square bars to create these two diagrams that I'm showing you right now. All right, so now I'm going to use these 3/4 by 1/8 of an inch flat bar to create these short and long bars. Okay, these bars are gonna be used to place and fix the pumps using this project. All right, so now I'm creating the anchors that will be used to place or to fix some steel sheets or some metal panels with rivets. And the size of this flat bar depends on you. In this case, I'm just using a 1.5 inches flat bar, but you can also use the 3/4 of an inch flat bar if you will. And now I'm removing the sharp edges of these anchors for safety concerns. And I'm using this special tool attached to my bench drill to create holes in each of these anchors in a safer manner, okay? If you have any ideas on how to automate or increase the efficiency of this process, please let me know. And this is the result. I welded the two square bars correctly to the main structure. And now I am just welding the perpendicular square bar. This bar will be used to create a frame to place the MDF panel that will allocate all electrical and electronic circuits. And this is how it looks. I also welded the 4 anchors, and that will be used to attach the MDF panel that I previously mentioned. Okay. And now I am giving the whole structure and welding spots a better finish using the angle grinder and a flap disc. And now I am welding the other set of 4 anchors to place the protective metal panel. This metal panel will be used to protect, as I said earlier, the electronic enclosure. Okay. And this is the final result. And well, I didn't record this part of the process, but I also placed another set of 2 square bars just below the others that I just welded. Okay. And well, these square bars are the so-called second floor, and they will serve to allocate the wire pumps. And this is the result. Okay, so now I'm going to place the flappers to allocate the motors. And this is the final result. Remember that you have to be very strict with the dimensions used, because otherwise the motors will be harder to fit into these bases. Okay, and well, this is the overall outcome. Okay, and now I'm going to place the cylindrical hinges, and this is the schematic diagram I'm going to use to cut the protective metal panel. And well, I'm going to use the angle grinder again. And well, this is the result. Both doors work. And well, I also welded the 4 anchors or thread rods. And I'm going to cut the main steel panel. This is the front panel. And well, I'm going to use this chop saw to balance the weight. And now I'm going to create the holes for the rivets in the front panel. This is how it looks, the front panel after the riveting. And now I'm going to create the holes for the buttons and the PVC piping. Okay, I use some special tools to create these holes. And well, this is how it looks. I created a hole for the LCD screen, the condensator, and the special function button. And now I think it's time to paint the whole machine. Remember to clean the entire surface to avoid any painting defects. And this is the final result. Okay, as you can see here, it's very smooth and clean, and the machine looks very beautiful with this specific color. Alright, so now it's time for the assembly process of this machine. And well, this is a complete set of components I used, in case you want to take a picture of them.
Alright, so the first step is to place these arcade buttons in this exact order. So this is the result. Alright, so I'm gonna show the buttons from the inside of the machine. Alright, so here they are. Alright, so the next step is to place this condensator. This specific model is the SR500, and let's see how it looks. Alright, so this is how the condensator looks. It's very solid, and well, now the next step is to place these 10 pumps. These are the ratings of the pumps. Okay, 12 volts, 6 amperes, 72 watts, 6 liters per minute, and 0.9 megapascals. Okay, and this is a brand good pumps. Right, so I'm gonna use these screws and these nuts to place them. Okay. Alright, so these are the pumps. As you can see here, there are fits to the chassis using these screws. And well, this is how they were mounted. And now we are going to connect the hose, okay? And well, I use these adapters, and I'm going to use these elbows and these connectors, uh, and I'm going to place them at the front of the machine, and I'm going to use these connectors as well. Alright, this is how it looks like. I think it looks a little bit messy, but well, I think this is very clear what I'm trying to do here. This is the first pump, it is connected to the first output. The second pump is connected to the second output. The third is not connected yet because it has to be connected in this place. But since there's not enough space to place the adapter here, that's why I just didn't connect it till now. Okay, and well, this is the fourth pump, and so on till the last pump. Okay, so now I'm going to connect the arcade buttons using a 2x4 matrix layout, and I'm going to connect all the pumps to the main part of this machine, okay, which is the electrical circuit, and it's going to be here. Okay. Okay, so this is the layout I'm going to use for these buttons. I'm going to use a 2x5 matrix layout, and we'll just call them number 1, number 2, number 3, number 4, number 5. This is the first row, and this is the second row. Okay, so this is how the real circuit would look like. This is the first button, the second, the third, the fourth, and the fifth, and so on till the last button, which is button number 10. Okay, so I tried to use the minimum amount of cable to create the circuit, so that's why I use this pattern. So this cable is connected to this other cable, as you can see here. Left 10 and left 9 are connected. Okay, left 8 and left 7 are connected, as you can see here. And well, and so, and then, for example, 10 and 8, well, right 10 and right 8 are connected, right? And right 8 and right 6 are connected, as you can see here. So that's what I did here. So this is used to make the circuit as cheap as possible. All right. And the next step is to 3D print these bases. Well, they are used to protect the LCD screen. And I use these screws. Okay, so I'm gonna show you how it looks mounted on the vending machine. So I inserted the LCD screen into this thinner plate, and I'm going to mount it on the vending machine. So I'm going to show you how this machine works internally. As you can see here, well, these are the 10 pumps I'm going to use for each product, okay? And well, they are connected to the outputs of the machine using these fuses, okay? And well, these are the buttons, and all these pumps and buttons are connected to the main control part of this machine. So this is a control board of my machine. This is the PIC16F887. This is the, well, a 5-volt regulator, the 7805 regulator. These are two 74HC595 serial registers that are connected directly to the relay modules. These are two 7493 binary counters that are used to count the number of pulses received from the conacceptor. These are, well, this is a 4N25 optocoupler that is used to reduce the number of noise in the signal that comes from the conacceptor. And this is a 74HC14 Schmidt trigger that is used to, well, to increase the hysteresis of this control board. Okay, and well, obviously this is the most important part. This is the power supply I'm going to use for this project. This is a 12 volts, 20 amps power supply, and well, it's very reliable. And honestly, I added this 10 amps fuse to protect the circuitry, and this is just the distributor I use to distribute the ground across the circuit. Okay, so well, obviously some things that could be enhanced in the future is this control board, obviously, because I could have designed a PCB.
So this is the final part of this video, and I just want to say my conclusions on this project. For example, well, I have to say that this project has a very bright future because it accomplished its main goal, which was to create a low-cost, reliable, and safe vending machine. And well, if you compare the price of this machine, which is around $300, to the prices of other machines that are here in the local market in Mexico. They cost around $3,000. So it's a very impressive gap between prices. And well, other areas of improvement of this machine is that we could replace this 8-bit microcontroller, which is the PIC16F887, with this STM32 microcontroller, which is a 32-bit microcontroller which has more computational power. And with this microcontroller, we could use, instead of using this old-style LCD screen, we could use a color screen. Okay, and well, we could add Bluetooth connectivity. We could add Internet of Things connectivity. We could add maybe SMS communication for emergency warnings. We could add flow sensors, more fuses, as I said earlier, etc. But on the part, when it comes to manufacturing, we could use machining instead of using blacksmithing tools, or we could include more complex mechanisms to make this machine more reliable. Okay, and well, for payment methods, we could add this. We could add this payment terminal to use credit cards, debit cards, maybe Apple Pay, etc. Okay, and well, I really have to remark this part because I use cheap pumps because my budget was very tight. But maybe in the next version we could use these industrial grade pumps, which are far more reliable and powerful. And well, finally, is a suggestion for those of you who are interested in inclusion and that. I think that it would be very useful to include these speakers because there are some people in the world that they don't have the same capabilities to interact with menus, and well, it would be very useful for them to maybe receive orders and information using these speakers. Okay, especially if they are elderly people or maybe people with vision problems, etc. So I think that's it for this video. Thanks for watching. Remember that all documentation is below in the description for free, and have a nice day. Goodbye.